everybody. We're starting just a couple of seconds late. We were just getting everybody on board there. I'd like to welcome you to the next episode in our Open Networking webinar series. This time it's Public to Private Cloud Network Deployment, a step-by-step guide. And we're delighted to be joined by Cumulus for this webinar. My name is Ciara McCarthy and I'm the Global Marketing Director at EPS Global. So just to give you a bit of background on EPS, we are the open networking distributor of choice globally for a whole host of industries. We sit at the center of the open networking ecosystem. So we bring together the hardware and the open network operating system software to create turnkey solutions for our customers. We offer technical advice, configuration of the software and the hardware bundles. So that's everything from switches to optics and cables and more, whatever you need for your deployment. We've been around for 20 years and we have 28 global locations, so we're never far away from you. So just a bit of housekeeping for today. If you have any questions, if you put them into the Q&A window of Zoom, and then I will introduce you now to our guest speakers. Okay, so first of all, we have Barry McGinley, who is our systems engineer at EPS Global for EMEA. He's our resident techie with a broad knowledge of open networking. So Barry enjoys a pint of Guinness and he is an avid Celtic supporter. I'll let him speak for himself later on, but he writes a really excellent blog that you can find on our website at epsglobal.com. The next person who's going to speak today is Neil Simonson from Cumulus. He's a regional sales manager. So he is a regional sales manager based in the UK for Cumulus Networks. He has been working in the IT industry since the early 90s, with the last 10 years focused on sales working with disruptive startup vendors in both storage and networking. After Neil, we're going to have Pete Crocker, who is a systems engineer for Cumulus Network, and he's also based in the UK. So he works for Cumulus, the company that pioneered the open networking movement. He's been involved in large enterprise and service provider networking solutions since the 90s with customers across EMEA and the world. His passion is helping engineers move towards automated and intent-driven infrastructure and away from time and mind-consuming artisanal network configuration. So again, any questions you have today, if you pop them in the Q&A window, we will answer them at the end, and anything we don't get to, Barry will respond to you personally afterwards. Thanks, and I'll hand you over to Barry.
Thanks, Ciara, for the lovely introduction. So as Ciara mentioned, my name is Barry. I'm a network engineer with EPS. I've been working with EPS now for about 2 years in the open networking space. So my job basically is to be a bit of a conduit between our customers and the vendors, because open networking can, from the outside looking in, be a bit daunting. You have a lot of software vendors, a lot of hardware vendors, so we kind of pull all that together and just make things a little bit easier, I suppose, in open networking. So what we're going to look at today, a little intro into EPS and what we actually do in open networking. I'm going to look at public cloud and the associated challenges, which leads us into an initial customer interaction. So a customer is going to come to us with a certain issue, going to kind of set a scene for a deployment. Neil is then going to take us through an intro to Cumulus Networks. We're going to look at some of the products, NetQ, Cumulus Linux itself, and he's going to look at the virtual experience like a POC. And then we're going to have Pete take us through from POC to day 2, looking at automation, monitoring, and the actual deployment. So EPS, so as Ciara mentioned, we're 20 years old, and since 2016 now, we've been involved in the open networking space. So this all came about, we became global distributors for EdgeCore Networks. EdgeCore are an OEM, ODM switch manufacturer owned by the Acton Group out of Taiwan. And if you've used a switch that's not Cisco, you've more than likely used an EdgeCore or Acton Group switch. But I think it became apparent pretty quickly with the relationship with EdgeCore that the normal distributor role doesn't apply, because the hardware is only one part of this solution. So what we did was we went out and talked to the software guys, all the software guys, because that's an important distinction for us, that we don't pigeonhole a piece of software in somewhere that it shouldn't be. There's specific use cases for these and there's a best fit. So what we're talking about today data center deployment, Cumulus is more than likely the best fit, best support, a really good product. We also offer a couple of other things for our customers, again, to try and ease any kind of negative stuff in open networking. So we can put the software on, so say take Cumulus, for example, we can put the operating system, the license on the switch, we can bundle in transceivers that we know will be interoperable, cables. So basically the switches are ready to slide into a rack, which definitely takes some of the pain out of open networking. Okay, so what I'm going to do is a quick high-level overview of cloud computing. I know all you guys are going to know what cloud computing is, but I just want to give some facts and figures as well before we go into some of the issues with cloud computing. So the biggest companies out there, AWS, I think everyone knows, is the largest. Microsoft Azure catching up slowly but surely. Google Cloud, VMware Cloud, Oracle, IBM, and Alibaba with about 4% of the market, up from 2% last year. So, and just to bring it back to open networking, all these guys use bare metal and open source. It kind of started with Facebook back in about 2012, but then all these guys got involved. So the hyperscalers all use it. And this is what we're seeing since 2016, 2017, that kind of bare metal open source software like Cumulus filtering down into enterprises and even small to medium businesses now. So the cloud computing market last year was worth 206 billion. I think it's projected to be about 350 billion by 2023. So it's going nowhere. Software as a service was about 100 billion of that figure. Infrastructure, platform, business process as a service, all around the 30 million mark. Then we have database as a service. And the largest growing area by a mile is container as a service. So that's your Docker and Kubernetes. I'm going to show some facts and figures actually as well, because there's a company, RightScale. They're a software as a service provider. And every year for the last 3 years, they've produced a fairly comprehensive survey called the State of Cloud Computing, where I think they sent out 150,000 surveys, but they got 997 surveys back with a good kind of separation of big and small companies. So around half were over 1,000 employees and the other half under 1,000 employees. So a good spread. But basically from that document, the average enterprise is using 4 clouds. So whether that be AWS, Azure, Google Cloud, and their own private cloud, the average cloud is actually 4.2 clouds, taken all in. But in the 2019 document, it actually talks about an increase in public cloud. So coming back from private cloud to public cloud. And I want to just look at a few of the reasons why this is actually the case. So there is problems with cloud computing. The first one is managing cloud spend. So all these companies, AWS, Google Cloud, Azure, have great deals for starting off, but then the great upsell begins and you can start to see costs spiraling fairly rapidly, especially if your company's growing. And as you move more of your workload to the cloud, costs increase significantly. Cloud governance is an issue. So again, when companies started small with maybe doing some software as a service, and then it started to grow rapidly, they never actually put in the company governance that they should have. And then they end up with most of their workload in the cloud, a lot more employees than they started with. And all of a sudden, governance is a huge issue. Security is an issue. So when you think, if your data has been held by a third party, security is always an issue. You don't know where your data has been, where it's being processed. When we've all seen hacks, hacked interfaces, APIs, it's always going to be an ongoing issue if you cannot see and you don't know where your data is. Compliance. So we've got a lot of legal stuff in every walk of life. So you look at the healthcare industry, there's huge regulation in that. Retail industry, huge regulation as well, to do with payments, to do with data. So compliance is a massive issue. Lack of resources or expertise. Again, this goes back to I was saying 4 clouds is the average, but that can be up to 8 clouds. You need an expert for each one of those clouds. The tools are getting more and more complicated as the weeks go by. These guys aren't cheap. Managing multiple clouds is an issue. When you think of so say again, we've 4 clouds. AWS has its own specific issues, but those issues with Azure are completely different. So you're managing a set of issues from 4 different cloud providers. Cloud migration is an issue. We have, when you're moving a new application to the cloud, it's quite easy, but an existing application is particularly difficult. So I think in that Right Scale survey, they said that over 50% of people said it was way more difficult to move an existing application than they expected, way more costly, and the project ran way over time. And then finally, performance is an issue. So all of these companies have had outages over the last few years. If they have an outage, you have an outage. That is definitely a worry. So as I said, we've seen customers over the last couple of years moving back to a hybrid cloud model, definitely taking some of their infrastructure back from public to private for a bunch of reasons, which I just explained. So what way does that kind of take place? So the customer contacts us, says he has one of these issues or multiple of the issues. And then the first thing we look at is the software. So we ask them, what do they actually want to do? What do they need? So it's a data center implementation. What are they looking to use? EVPN? Do they need any particular protocols? Do they want to use VXLAN? So we'll take all this into account, and then we'll select either one software or 2 softwares for them to trial. So in this case, obviously, we're going to be looking at Cumulus. For the data center, Cumulus is the standout operating system, best support going as well. So once we've selected our software, we then will look at the hardware side of things. So on the hardware side, again, we've multiple options. So we've got Edge Core networks, we've got Mellanox, we have Quanta, Delta, Celestica. And then as well on our website or on Cumulus's website, we have hardware compatibility lists. So we can see which hardware we can actually use with this software. And as well, certain softwares, so certain of the switching ASICs will do certain things. So say we're going to say for this, we want 25 gig for the leaf and 100 gig for the spine. So a 7326 from Edge Core with a Trident 3 chip and a 7726 100 gig with another Trident 3 chip. So right, we've selected our hardware and we now have our software. So now we have to start initial testing. So there's a couple of ways around this. What I always like to do was to get hardware into people's hands. That's what I liked. So we'd give maybe 3 boxes. So you'd get 225 gig and 100 gig, so you could simulate a spine leaf topology and then work away on that. But there's now a bunch of different options, some really good options virtually that you can do before or you can do in parallel. And this is actually the point where I would bring Cumulus into the equation. I would bring Cumulus's SEs in and we'd start talking to the customer. And that's a nice segue for me to bring Neil in from Cumulus, who is going to give you an overview of Cumulus and some of the products. Thanks.
Fantastic. Thank you, Barry. I think, Barry, if you could end the share. Fantastic. So, yeah, thank you, Barry. Thank you so much for that. So, yeah, continuing on from where Barry left off, just a sort of introduction to Cumulus and a little bit about the background. It probably highlights a little bit of the thoughts that went into the formation of Cumulus right at the beginning. So, Cumulus was founded in 2010 by J.R. Rivers, and J.R. Rivers was a person with a tremendous industry experience, and he culminated his actual work experience with a couple of years at Google, as well as a long-term tenureship at Cisco. And I think it was the bringing together of those two worlds, his experience at Cisco and the experience at Google, that demonstrated that something had to change with the traditional networking and how we deliver traditional networking. And so what we see is that JR came to market in 2010 with Cumulus as the first open network operating system built, purpose-built for the DC. So this is a network operating system, Linux-based, that runs on bare metal switches, And it allows you to make use of all the operational tools that you have running in your environment. Today we have many Linux instances, services, etc. So the tools and tool sets that we make use of to actually automate and to run those at scale are now applicable to the switch running the Cumulus operating system. So if we compare this to the traditional data center networking model, moving from left to right in the slide, we have on the extreme left-hand side the traditional legacy vendor. And here we can see that this is a proprietary world. It's essentially networking on rails where your vision is dictated by the vision of the network vendor themselves. And it's proprietary, often proprietary protocols. Interoperating between these different proprietary legacy network vendors is very difficult. So it's very much a closed ecosystem. As we move to the middle, we start seeing this advent of open networking. And here we get this term disaggregation. Now, most of us are familiar with disaggregation because we've been doing it for many, many years in the server world. This is the whole opportunity of being able to select the correct hardware, match it to the correct software to deliver on a specific need. So a great example is the fact that today you can choose an AMD CPU or an Intel CPU. You can choose which vendor you would like to get your hardware from. You can choose the operating system, whether it's Linux or whether it's a traditional Windows Server-based OS, but you have the ability to build out your model in your DC as you see fit. So this is essentially what we're doing with the open networking models, bringing that into networking, disaggregation, allowing you to choose the exact match of hardware, the exact match of operating system to deliver on your requirements. Where Cumulus goes with this model, moving to the right, is that we not only have Cumulus Linux, the actual operating system, but we add to this NetQ to give us the visibility that you require, visibility and analytics that you require in a modern DC environment. So what does open networking mean to you? So first and foremost, disaggregation is a way of driving down the hardware and operational costs. So firstly, we can choose the right hardware model. We can choose the right level of support. We can choose options such as self-sparing, but allow us to choose the right hardware models fit for purpose in your environment. For example, the requirements in a core DC are very different from those for a small test dev environment. Secondly, we bring in the concepts of simplification and scale. So part of the ethos of Cumulus is to build out simple models, simple configurations to allow you to achieve what you need in the modern DC environment. So things like spine leaf architectures, EVPN, etc. But we simplify these configuration processes and we deliver those at tremendous scale. The easier to manage and the flexibility and control of the architecture comes from the fact this is a Linux-based operating system. So as we've mentioned already, you can make use of the common tool sets, the Puppets, the Ansibles, the Chefs that are already in your environment, probably already using to automate existing architectures. You can now extend those down and bring those into the networking part of your DC model. And then obviously added to this is the ability to automate and bring in agility and to do this at tremendous scale. So it's a single operating model across the whole of your DC. In terms of Cumulus NetQ, this is a product that then brings the full visibility and troubleshooting into the environment. So this allows us to look at what's happening in real time in our environments, have a look at top talkers, have a look at trace routes, etc. So have a look at all the configuration parameters and performance parameters in your environment. But most importantly, NetQ adds to this the concept of historical reporting. So not only can we look at what's happening with the visibility in the environment right now in real time, but we can also do this in a sort of what happened in history perspective. So the ability to look at what happened at 12 yesterday, when the network was slow, when the network was not responding correctly. And this obviously reduces the mean time to innocence. So the ability to, we all know the problem of that it's always the network's fault. So being able to go in and have a look at exactly what was happening in the environment in a given moment of time historically allows us to, shorten that mean time to innocence when it comes to the actual networking configurations and performance. So NetQ obviously gives us the unprecedented network visibility, advanced telemetry and deep analytics, but it also adds, very, very sophisticated lifecycle management, so that you can now manage the complete environment from this single NetQ interface. And it's an open and extensible architecture, which means that we can grow this out, from anything from a couple of switches to many thousands of switches in a very advanced DC environment. In terms of the ways that we can actually that you can actually experience Cumulus, I think this is one of our big advantages, being a software-defined operating system. We enable you as the end user to experience us in many different ways with a commonality of the code base across each of those methods. So firstly, you have the ability to go onto the Cumulus website, sign up for a try in the cloud. And this is where we spin up an instance, a Cumulus instance, and allow you to actually go and kick the tires, so to speak, but to play with a simple deployment that allows you to experiment with the command line, to experiment with NetQ, to understand how Cumulus works in that very safe sort of sandbox virtual environment. But moving to the middle, we can actually also provide Cumulus as a virtual instance. So the Cumulus VX, which you can download and then you can deploy in virtual architecture in your environment, in your existing environment. So if you'd like to model the exact physical environment, you can do this with multiple virtual machines. But maintaining again that complete code compliance and code compatibility, so that any configurations you've already made use of in the cloud can actually be then deployed on the virtual instance. And then finally, working with EPS, we can also provide physical switching. If you would like to actually do a POC on the physical switch, we can do this. We can issue temporary licenses. You can deploy physical switching in the environment. And obviously, this is really, if you look at the first two steps, this is not really much of a requirement, because the only time you really physically would like to actually perform a POC really comes down to if there's some physical requirement in the environment. So perhaps it comes to absolute latency or some sort of physical behavior of the switch that you'd like to look at. But the reality is that if it comes down to the actual functionality of the Cumulus OS, you can perform all of this in the cloud or in the virtual instance. So what I'll do now is I'll hand over to Pete, and Pete is going to take us a little bit further through the actual way that you can experience Cumulus in your environment.
My name is Pete Crocker. I'm one of the systems engineers here at Cumulus. And what I'll start off with is, first is a bit about why did you go to cloud in the first place? What were some of the benefits that your organization was looking for when you went to the cloud? And how do you actually still maintain those benefits while moving some of your infrastructure back to an on-prem based deployment? So we'll start off with a bit of control, right? And this is also closely tied in with security. So by moving to the cloud, oftentimes you end up losing some visibility about what's actually out there. And in some organizations, this ends up introducing shadow IT, where due to the lack of ability for a network team to be able to respond quickly to business needs, to roll out new services and applications, those other teams end up getting frustrated with the network department and end up going around them. So that ends up meaning a lack of understanding about where applications are deployed and what is the security profile on those applications on all the various cloud providers, and ends up creating regulatory issues, compliance issues, because they can no longer understand actually what's out there and how is it being monitored and secured. So by bringing some of that critical infrastructure back in-house, you can end up getting that control and security that you need in order to run your business and stay compliant. But you still want to maintain some of the other benefits about why people went to the cloud in the first place. So another part of that is total cost of ownership. As we've seen with multiple people as they've migrated their applications to the cloud, as Barry was mentioning, oftentimes the first deployments will be small and manageable and reasonable from a cost standpoint. But as they start understanding the billing structures and the scale of the infrastructure that needs to be moved to the cloud, or the cost of data transfer, for example, back and forth to their cloud-based applications, those costs end up spiraling out of control. And so you don't end up actually having a forecastable amount of ongoing OpEx to be able to understand how much IT spend to use for these various cloud providers. So bringing some of that infrastructure back in-house allows you actually then not only to understand the upfront CapEx that you need for that, but certainly being able to have predictable ongoing OpEx spend as well is a big benefit. Now, the original reason why some people went to the cloud was to provide flexibility and possibly scalability. So being able to respond to the business needs, be it to spin up a port quickly, to deploy some new hosts or VMs on the network. Those other departments don't want to wait days or weeks for a VLAN to be provisioned. So you need to be able to provide flexibility and timely responses to those other departments so that they don't end up trying to essentially bypass the networking team in the first place. Not only that, you need to be able to scale to keep up with whatever the demands are. Certainly, as we're all seeing right now with COVID-19, the needs for some given application, be it something like remote access or VPN or bandwidth for your remote employees, you need to be able to rapidly scale up parts of the infrastructure and do that safely and in a controlled manner. So we'll talk about how you can do that with Cumulus here as I go through this in a minute. And also along with that is vendor lock-in. So not having to be tied to any one, for instance, specific hardware vendor and what their offerings are helps out not only with specialized and short-term deployments, but also in regional availability across the world, where you may be able to source hardware from one vendor much easier and get better local in-country support in one part of the world than you would somewhere else. So having a common operating system working across a wide variety of hardware options allows a lot more flexibility and gives you more control over what your path is going forward. And then finally, as you move towards more rapidly responding to the business needs, you need to be able to safely make changes and mitigate risk whilst being able to maintain this flexibility and ability to rapidly roll out new services. So the overall method of you doing configuration changes on an ongoing basis and trying to actually bring down the risk of making changes is a crucial part of the overall deployment of these services to be able to keep up with the demand from different departments and organizations. So what I'll do is I'll go ahead and walk you through all the way from a proof of concept through deployment onto day 2 operations. As we go through this, we'll go ahead and talk a bit about automation. What is your starting point from a configuration standpoint, and how can you rapidly roll out these changes? We'll go ahead and talk a little bit about simulation here as well. What value does that actually bring, and how can you actually do a one-to-one test with what is the proposed changes versus what's actually in production? And then once you actually bring physical hardware into the mix here, how can you rapidly plug in those network switches and bring them up and make them fully operational? So we'll talk about a rapid deployment. Once the boxes are actually deployed, then you want to move into monitoring and troubleshooting capabilities and make sure that you've got full visibility of that infrastructure and you can rapidly respond to any types of problems or changes. And then finally, we'll go ahead and get into how do you do ongoing changes to try and mitigate risk, but still rapidly be able to keep up with the demands in those environments. So I'll walk you through step by step of this. The first part of this is automation. So what Cumulus has done is we've taken years worth of our consulting team's learnings of deployments from various customers, and we've essentially open sourced all of this. So this is not only reference configurations about if you want to roll out a data center and you want to roll out a leaf and spine architecture, and potentially on that you want to roll out VXLAN and EVPN services in one of a few different methods. then we're going to take the best learning and of what those configurations should be and use that as a starting point for every one of our customers so that things can be as similar as possible. Not only does that help you for the sake of managing your overall configurations, but that also helps us support you that most of our customer deployments are using essentially the best practices here. But this doesn't just end with configuration reference examples. This is actually a live repository of taking all of the learning around automation as well. So we're bundling in with this all of the automation tools and playbooks necessary that if you want to go down a path of using automation from day one, then we're actually handing to you all of the best practices from an automation standpoint as well, so that you can instantly use something like Ansible to configure this entire infrastructure. And it doesn't even end there. There's also monitoring portions of this built in and continuous integration functionality if you want to take advantage of it, which we'll touch on here at the end. So Cumulus is giving you the best of our learning and open sourcing this so that ideally every customer can start off with using this as their starting point. Now, if you want to do a proof of concept and test out this environment, what we typically do is work with what would be the actual production configuration of the devices. So not necessarily just testing 2 or 4 switches in a lab and playing around with the various functionality and making sure that it works. But a more ideal case is let's go ahead and actually come up with what is the final data center configuration down to every single port and how is it cabled, every single configuration statement, every protocol, the exact configurations that you would deploy in the production environment. And Cumulus has a virtual instance of our operating system. And by the nature of it being a full Linux distribution, how our virtual instance works is the same as how the physical devices actually work. So what you simulate, what you can spin up in a virtual network environment will end up actually being the same functionality, the same code that will actually run on the production switches. And what this allows is you can do a full simulation of the exact production deployment down to every single config statement and port, and do your testing of Cumulus to see if it works for you with how you would actually roll this out. And one of the tools to make this easy for you is you can either spin up this virtual environment on one of your internal servers, or you can actually use Cumulus to do this. So our Cumulus in the cloud service allows you to spin up this entire virtual data center essentially on our servers. And then you can remotely SSH into each of the networking devices as if they're physical switches and do much of your upfront testing with the exact production deployment, work out the exact configurations, go through various testing and failure scenarios, put hosts on the end of it and actually run real application traffic through this if you'd like to. So the infrastructure to test a full data center deployment doesn't mean that you have to start off with racks worth of switches. You can work out most of this in a virtual environment without even deploying anything locally at first. So Cumulus in the cloud allows you to instantly and rapidly spin up the full production deployment virtually first. So you've done all the initial configuration, you've got production ready configs ready to go, and now you need to start plugging in switches. Oftentimes people during proof of concepts want to do failure analysis. What happens if the power fails on a switch, or you unplug cables, or you actually want to roll out the real production deployment. So there's a few parts of this to make that deployment of the physical switches actually as easy as possible. Now, in the open networking market, You may have a switch, for instance, that has no operating system on it, or an alternate OS installed on it. So Cumulus, a number of years ago, wrote the ONI bootloader. So this is similar to Pixie in the server world. So you have a bare metal switch, and you need to get an operating system onto it. So the standard now across the open networking market is to use the ONI bootloader that Cumulus contributed the open source to, so that you can actually get an operating system onto the box if you need to. Now, many times when you're purchasing the devices, you'll get Cumulus pre-installed on the switch for you. And so EPS, for instance, is our partner responsible for putting together the hardware, the software, and even installing license files onto the switches in advance so that you don't need to go through this step. But in the event that you needed to rapidly re-provision a switch for a different use case, then you can instantly have it boot its OS over the network. Then you need to get an initial configuration onto the box so that it can be reachable. So you have Cumulus installed. Now you want to put, for instance, a static IP address and a base configuration onto it so that you can remotely access that switch. So the ZTP boot, zero-touch provisioning functionality built into Cumulus allows it to boot an initial configuration so that you can remotely manage the switch over the network. Now, oftentimes when you're rolling out these switches, you'll have remote hands in a data center in another part of the country or halfway across the world actually physically plugging in the switch for you. And you've given them a plan for what ports get plugged in with which cables. And oftentimes those things don't always go to plan. So Cumulus also open sourced a tool called Prescriptive Topology Manager, PTM for short. And its job in life is to verify that the switch has actually been physically plugged in properly. That if you have switch port 1 on a spine switch, you know that it should be plugged into switch port 1 on a leaf switch. And so when your remote hands are running around actually plugging in dozens of different devices, you can, with a single command, then verify that actually everything has been physically cabled properly. So you go from no OS on the box all the way through to verification that the switch is cabled and plugged in properly. And now you're ready to actually move to putting the production configuration onto the device. And since Cumulus is a standard Linux distribution, there is no proprietary management solution here to lock you into our approach. If you have a tool of choice, if you are using other automation tools to manage your Linux devices or other networking devices in your infrastructure, then those will all work well on Cumulus. There's no proprietary needs here. So many of our customers tend towards Ansible to do this because it's one of the most approachable tools for network engineers. But we've got quite a number using various other open source and commercial tools out there to manage the devices as well. That said, there's always a command line on the device that looks like other networking device command lines. So you can still individually manage them just fine. But again, trying to rapidly meet the needs of cloud-based deployments and bring that same level of flexibility and responsiveness internally, many of our customers are now doing that migration over towards trying to automate as much of that infrastructure as possible. And since Cumulus is handing you that production-ready automation to you, that makes that journey easier as well. So choose your automation tool of choice and use that using our Golden Turtle reference configuration and automation to be able to rapidly deploy this equipment. And since you've done all of your configuration testing and validation and working all of that out in a virtual environment, the only step here is basically just a one-time push of that config out to the network device itself. So within minutes, you can roll out a new switch and have it be ready for production use. You have the switches now deployed. Let's talk a little bit about monitoring and day 2 operations on these. So first, there is no one way to do monitoring. One of the nice things about Cumulus is this is a network device, standard network device. So if you want to use your existing tooling and do SNMP polling of the devices and have us just fit into that existing infrastructure, that's great. Do that. If you want to take advantage of maybe some more advanced Linux tools that your server and applications teams have been using, then you can take advantage of that as well and use Linux-focused tools. Since it is basically a Linux box with more ports, then you can take advantage of that. If you have gaps and you want to look at actually taking advantage of some more modern ways to do network monitoring, then one example I've shown here is using something like Prometheus and Grafana, which are very popular open source tools that are highly scalable to be able to provide you that type of streaming telemetry information from the devices to gather all of your link statistics and memory utilization and temperatures and fan speeds, and easily then go and graph this in a scalable fashion, but providing a lot of flexibility and some very nice visuals to be able to make sense of that data set. So that's one path. There's quite a few other paths that you can use to monitor Cumulus. Another part about this is modern methods of doing notifications. So one classic example of this is integration with something like Slack. You want to know when a BGP peer goes down, then have us send an automated Slack message to a specific Slack channel so that you can see these types of events in real time. So there's a few methods of doing integration of notification, either with existing systems or with a few of these more modern systems as well. Now, that's part of the overall monitoring and troubleshooting story. So this brings in NetQ, which is Cumulus's specific tool for gathering information of network events and giving you fabric-wide visibility of what's actually happening in your Cumulus estate. We're taking all of the event information from a switch. So this isn't just statistics, but this is every time a new MAC address or IP address gets learned on a port. Every time a protocol has something that happens. So spanning tree or OSPF or BGP or VXLAN or EVPN, any of that detail of what's happening on the switch is being sent to a scalable collection platform that's using behind the scenes, it's using scalable tools like NoSQL and clustering so that we can manage thousands of switches using the solution. And gathering that information is only part of this. It's actually the intelligent processing of that information gathered is what the real value of NetQ is. So we provide a command line and web interface, different tools for different use cases, so that you can do various things like a fabric-wide validation to make sure that all of the MTUs are set properly on the ports, or historical troubleshooting capabilities. This one is crucial, where someone has complained that there was a problem on the network yesterday at 2 o'clock, and now everything seems to be working fine. So rewind time, create the state of the network as it was yesterday at 2 o'clock, and run the show commands, do your trace routes that you want to do on that environment, and actually see were there any networking events or was there reachability on the data center or campus network at that point in time when someone was complaining there was actually an issue, as opposed to now when everything is working just fine. So NetQ rounds out that monitoring and troubleshooting capability to provide actually deep insight into the Cumulus infrastructure so that you can analyze and troubleshoot events as they happen or back in the past. In addition, NetQ provides lifecycle management. So if you have numerous switches, especially in larger data center deployments, and you're tasked with upgrading that to a newer release, you want to make sure that that path for upgrade is going to make sure that you're not going to cause any single points of failure, and do this in a logical way so that you can get this done rapidly and get back to your job. But at the same time, making sure that you're not going to bring down any combination of networking devices that could cause outages or reduce capacity. So these leaf and spine architectures are designed such that you can take any element out and have a failure or a box go down for an upgrade at any point in time. What NetQ does, though, is it intelligently comes up with a plan for that upgrade. So identifying what the roles of each of the network devices is, be it spine and leaf, for example, and also looking at where boxes may be working in pairs, such as when you have an MLAG pair, where you only want to take down one box at a time in an MLAG pair and make sure that box is upgraded successfully first before moving on to the other MLAG member and doing an upgrade. So it goes through, it does a series of validations to make sure that each of the boxes will be successfully updated. It comes up with an ordering plan for how to upgrade the entire infrastructure of the devices you choose to at that point in time. It does various pre-checks and snapshots and comes up with a rollback plan. And then assuming all of that is well, then it will actually start and go through this upgrade mechanism for you. So it takes a lot of the pain for you having to come up with what is the most intelligent and least affecting method of applying updates across a wide infrastructure. So you've taken care of monitoring, you've taken care of upgrades. The final bit of this is actually looking at making continuous changes to this environment. So one of the reasons why people have gone around the networking department in the first place is oftentimes they're slow to make changes. A team comes to you requesting, for instance, that they get a port, they can plug in a server, they get a VLAN assigned, and those requests take potentially days or weeks to be done because of the network team's inability to safely make changes quickly. So Cumulus is trying to shift over towards more modern methods of reducing risk whilst making changes. So you have a proposed configuration change. Since we have the ability to simulate that full data center environment one for one with the exact configurations of what's running in production, you can spin up the entire data center in a matter of minutes. You can then test out your proposed configuration changes. So if you have your own server for doing the simulation, great. If not, you can come back to us for Cumulus in the cloud for doing this. You then test out those various changes. And then typically what a network engineer does at the end is they run through a series of show commands or ping tests or various other things to essentially make sure that the change worked. But oftentimes there's a lack of visibility about was there any unintended consequences here along the way. So there's a number of other pieces here where Cumulus can help you understand when making changes to validate that not only did your test, your configuration change succeed, but it has the intended consequences, and more importantly, that you didn't cause any unintended consequences along the way. So for example, our Golden Turtle automation repository comes with continuous integration elements built into this that you can instantly take advantage of. So the idea is that you would automatically spin up a simulation. It would run through a series of tests for you, validate not only that your change is made properly, but it can also take advantage of some of the features in NetQ, for example. Validate that not only are all my BGP peers up, but they're actually exchanging routes and the correct address families are functioning. Make sure that all my VXLAN tunnels are functioning properly. Make sure that EVPN is working. Make sure I have matching VLANs everywhere. So there's actually a deep series of validation tests that NetQ can do across the entire fabric to ensure that you're not causing any unintended consequences along the way. Ultimately, what this gives you is better visibility into changes and trying to help mitigate the risk of doing those changes more often in these environments, and better able to respond to the business needs. So rounding that all out, what you have is, from an upfront POC, the ability to actually do testing of the entire data center, all the way through deployment, through day 2 monitoring and management, and finally to the through lifecycle management, all the way through rapidly being able to make configuration changes in a much more understandable and safe way. So with that, I'm going to go ahead and hand this back over to Chiara, who's going to round this out for you. Thank you.
Okay. Thank you guys for speaking. That was really excellent. We just wanted to, before we get to the Q&A, just run through some of our upcoming webinars. Excuse me, our next webinar is with IP Infusion on the 23rd of June, and it's going to cover data center and service provider solutions. The following one then is with Apstra Data Center Network Automation, which is on July 21st. After that, then we'll have Pluribus Networks talking about innovations in open networking and SDN automation on the 25th of August. Then we are going to be talking with Pika 8 on the 22nd of September, going through On the Threshold with Open Campus Networks. And then finally, the kind of wrap up to our open networking series of webinars is our live Q&A with Barry in October. So Barry, you can move on there to the next slide, please. Okay, so this is just some contact details there. If you want to get in touch with Barry, he can answer any questions after this that might come to you after the webinar. Also, you can connect with us on LinkedIn and on our YouTube channel there. So I think then if I just jump to the questions that we have had, maybe Pete, if you could take this one. We had a question from Ernesto about what are the metrics that you look at when running a proof of concept, and how do you measure those? And he's talking specifically, what are the markers? What's markers you set when you're looking at if a POC is a good fit for the customer? And he's talking specifically about a spine leaf topology using EVPN and VXLAN.
So great question. I'll see if I can try and address both your questions here, Ernesto. I think the first thing that I typically try to understand from a customer standpoint is what is the landscape of existing vendors, and what is the need causing a consideration of something new, right? And that something new comes into a few different categories. So one is you have a refresh of an existing infrastructure. So your existing provider, vendor, maybe end-of-lifing old hardware. Another one could be you have a new business requirement, and oftentimes I see this driven from groups outside of the networking department. So common ones these days are your server and applications team wants to roll out OpenStack internally, or they're hot with Kubernetes. And so all of a sudden now there is a need on the networking team to be able to rapidly deal with a fast-growing server infrastructure around them. So with those, one of the things you have to figure out is how willing are you to introduce a new vendor into your environment? The devices, right? Some people get stuck with their one command line that they've been using for quite a number of years, and they have all their certifications around. And so you have a resistance to change from that standpoint, but from a higher level business standpoint, you have an IT department that's essentially saying, I need to automate and spin up VLANs in minutes. And those two conflicting needs end up needing to be addressed up front. before you can figure out whether or not open networking and Cumulus, or for that matter, any new vendor into the environment is actually going to be a good fit and successful, you have to try and make sure that there is a willingness in the organization to understand that change of how the solution works to ultimately accomplish your business needs is going to be palatable inside that organization. I think that one's probably key before we even start getting into technology discussions and, you know, what operating system, what switch is the right approach. Is there going to be enough of a willingness for these teams to be able to change? And oftentimes helping people understand that we can raise them out of their day-to-day drudgery of only making VLAN changes and getting back to actually using their brains as highly skilled network engineers is one of the biggest driving factors to help those people. And that kind of dovetails with your second question here, which is oftentimes people are, like I said, comfortable with their existing networking solution, and asking them to change that out is oftentimes quite scary. Cumulus specifically, we've got a command line. It's very friendly to your average Cisco network engineer. In fact, the routing stack that runs underneath it originally basically was a clone of iOS. And so there is some familiarity there. So even though there is Linux in the name of our operating system, to most network engineers, it works just like any other networking device does. And they'll still have all of their command line tools at their disposal. But that in of itself oftentimes isn't enough of a driver to change, right? Saving a tiny bit of CapEx spend isn't enough of a reason to shift all of the existing network deployment engineers and people who are responsible for doing monitoring of that infrastructure to support yet another vendor. Usually there's another driving need there about a need to essentially be able to respond more rapidly. Like this entire talk is about cloud, right? The applications and server teams are used to being able to run an API call and get what they want. And now the networking team has that same expectation put on them. And running around manually configuring boxes through SSH, doing bespoke configurations doesn't scale. You can't do 10 changes a month, 1 month, and then all of a sudden do 1,000 changes a month the next month and still be able to, in a risk mitigating way, keep up with that level of change. So usually it's some other driver like that.
Okay, so I hope that answers the questions there. Again, you've got Barry's contact details there up on screen if you want to follow up with him. I wanted to say thanks to Neil and to Pete for joining us from Cumulus today, and also to you all for joining us for this webinar. I hope it covered everything you need. We have a quick poll there if you have a moment to answer it. We do have a number of upcoming webinars, and if there's anything else you want to see as a topic in a webinar, don't hesitate to get in touch. So thank you all for joining us for today, and we'll sign off there. Thank you. Bye.